Hello everyone, welcome back to Let's Unbound. Yes, we are back with yet another new playlist for AP Precalculus students, and this will be focusing on Unit 3. As usual, we will have a concept overview plus 3 tier problem solving here. So let's get into this. First, this is about trigonometric functions, and in 3.1 we will learn the basic function thing, which is periodic phenomena. So how we are going to relate it with trigonometry, right? So let's get into this. So it's very basic and a straightforward topic, right? So it's a very easiest one. Periodic phenomena. So periodic phenomena means some events or behaviors that repeated at regular intervals. For example, you can take the phases of moon, right? It will be the same throughout the years and millions of years. It's been the same, right? So there will be a new moon which is completely black, then a crescent moon, it starts growing, and it will be a full moon, and then it will be waning, become a new moon again, and this will be happening again and again. The cycle will be repeating, and again it is 15 days gap, correct? So 15 days to become a full moon, another 15 days, and this at regular intervals and same behavior. This periodic phenomena, not only the phases of moon, even the waves, right? It is also following a periodic phenomena. And now in math and science, these are modeled using periodic functions like sine and cosine. So yes, sine and cosine are, we have learned it as ratio. Now we are going to learn them as functions, and they are periodic functions. They also behaves like the phases of moon. After a particular interval of time, they will keep repeating the same pattern. So they are periodic in nature, and that's the introduction. Now, graphs of periodic relationships. So not only sign, generally graph of periodic relationships will be, there will be repeated patterns of y values at regular intervals of x. So for example, x is equal to 1 to 4, sorry, 0 to 4. I got a pattern something like this. Okay, then 4 to 8 also let me just copy it for easiness. Okay. And it will be repeating the same process. This is called periodic phenomenon. It follows, it is periodic in nature. Then 8 to 12, it will be same. Even if you go in negative side, so at every 4 intervals, with the 4, the graph, the y values keeps on repeating, and I can observe that repeating pattern. And coming to this periodic function, periodic relationship. So what is the word period? Yes. When we solve in math problems, it will represent a number. It's very simple. The distance between repetitions of periodic function. So this is the period. It keeps repeating at the width of 4. So 4 is the period of the function. Some function will repeat just after 2. That's okay. So like your function is something like this, right? It has period 2. After 2 period, that is the 2 with the interval, it keep on repeating the same. So this is the period, and the graphs in periodic relationships looks like. Here is one example. It keeps on repeating a wavy pattern. And how to find the period from the graph? Very simple. You just look for the peak points and just subtract them, like finding distance between them. That is the length of the period, or one cycle, we will say. So 5, like you don't touch x values, y values for finding the period. You should touch x values. 5 pi by 4 minus pi by 4, which is 4 pi by 4, and the period is pi. Or you just take the minimum points. That also you can do. 3 pi by 4 minus of minus pi by 4. And if you simplify this, again pi. Right? So maximum, but sometimes, yeah, there might be some cases where this cannot be applied. It will not be that easy to apply this. And we will see that in question, like when we are solving problems. So very basic thing. And here we go. So what is periods? We already learned. The period of a function is a key concept in understanding periodic relationships. So after how many x values, it keeps on repeating. It is defined as smallest positive value k. For example, in one example, we did 4. After 4, it repeats every 4 gap. It follows the same structure. So we can algebraically define this. F of x plus k equal to, if you get f of x, then it is a period. It is a periodic function with period k. Okay. And it should work for all the x in the domain of the function. Now, what is cycle? The graph of a periodic function can be constructed from the graph of a single cycle. So, periodic means it will be going on and on. For example, this. Okay. So, I know the period. Like for example, 0 to 2 pi, it behaves something like this. Then I know it's going to repeat. You just copy down, copy paste it. And this is the cycle. One cycle and keep on repeating for many times. Okay. And this is possible in periodic functions because it's the periodic function will be consistent across all cycles. It will not change the behavior in different cycle forms. Right? So that's it. And now. Okay, so again a quick recall. The period is the smallest value, like a number, 1, 2, 3, like that, over which the function repeats its behavior. The period of periodic function is that length of one complete. So you take one complete cycle and find the length. That's it. So periods equal to cycles. And now, these are some properties. If your function is periodic function with a period p, then reciprocating that function will also have this, it will also be periodic and with the same period p. The value will be also same. And if f of x is periodic function, then f of ax plus p is also periodic, but the period value will change here. Your OG period divided by absolute value of the x coefficient. Again, if f of x is periodic with period p, then a times f of x plus p is also periodic and the period will not change, it's same p. Right? So these are some relationships. You can pause the video and observe this once. Now, let's solve questions. The following graph shows one period of a periodic function. Use the graph to answer the questions that follow. So it's a part of a function and one period is given, right? And many questions are there. First, let's complete this one. First thing is a function increasing or decreasing on or both on the interval 18 to 20. I don't know what is the behavior from 18 to 22, right? It's 20, it's given. But 22, I should find it. So let's complete the graph. So what is the period of this graph? This is one cycle, means 20 is the period, right? So at the starting, it is at this point, and here the next cycle starts, so same point. And 1, 2, 3. At 3, it has the lowest point. So after this, like at 23, you just add 3, 1. Then the 1 will appear at 23 because the period is 20. You will add 20. 23, it will be 1. Then I'm just taking some like where it's minimum, maximum, cross of x-axis, y-axis, those. And 5, 6, 7, 8. 6, 7, 8. Okay, at 8 it crosses x-axis. Then it will again crosses x. Like this point will be on a new cycle. 8, your period is 20, so 28. 26, 27, 28 here. Then peak point. 11, 12, 13 it's peak. Then 13 plus 20, 33 is the next peak. 31, 32, 33, the peak point. Then again it crosses x-axis at 16, 17, 18. Then at 20, at 38 it will cross x-axis. That's it. So this is how the periodic function is. Like actually it should be a smooth curve, but it is just at this. Okay. And we can keep on repeating. Right. So I think this is what we need. It's enough to answer the questions. 18 to 22, is it increasing or decreasing? Like we did it in the first unit, right? Increasing, decreasing natures. So let's see. So 18 to 22. This is my 18, correct? And this is my 22, 21, 22 here. So what do you observe? It's completely decreasing, correct? So we can say it's decreasing. And is the function concave up, concave down, or both on this interval 6 to 10? So let's focus on 6 to 10. Where is 6? So 5, 6 here. Go to the graph. And 10 here. So this is the width we are working. So is it concave or concave down? This way it's concave up, correct? Till this. Then from here it's concave down. So this part is coming up concave up and down, so it's full. Is there a relative maximum, relative minimum, or neither at point 16? So relative maximum occurs at 13, then 33, and like then 20, 53, like that. Minimum will occur at 1 to 3, then 23, then 43, like that. So the 16 will never come, and you can see that 16 is neither minimum nor maximum. Correct? So it's neither. That's simple. This periodic function and discussing the features here. Now, the graph of the function f shown in the xy plane, which of the following has the same period as f? So we should find the period of all of them which matches with the blue graph. The given graph will be the correct answer. So let's find the period of this. Okay, I'm just going for maximum is your x coordinate is 2, and this next to maximum x coordinate is -2. You should take consecutive. Don't take this maximum and compare with this. It's not allowed. Consecutive maximum distance or minimum distance. So this is -2 and 2. Like it's not 0. 2 minus of -2, which is 4. So the period is 4. Now I will check the options which matches with the 4 will be our answer. Let's do here. Okay, I can see the pattern. So if it's keep on repeating like this, no, we can't make. So let's calculate for one cycle. Maybe it starts here. It goes like this. It goes like this. It's one cycle I observe. Then it repeats the pattern, right? Like this. Correct. So I got my one cycle. And okay, let's go for maximum condition, but I'm not sure. Here it's not clear. It's just 2.1 or 2.5. We are not sure here. So what can I do? You can just guess it. Will that be in 4 units distance? No. This itself it's 4, and this is something 2. It's 6, and this is kind of. So it's of course it's not 4. Right? We are looking for 4. So in this case, we can reject the option A. Now here, let's see whether we got period 4. A maximum minimum again problematic because I'm not sure with the values. Maybe it is 5, but we are not sure. So don't take the risk. Look for a cycle. For example, if it starts here, it goes like this. It goes like this one cycle. Can you see it? And if you just copy paste it, the other thing. Then like that we have to follow. So this is I find one cycle. Now let me try to find the length of the cycle. This is 4. This is 0. So it's 4 minus 0 is 4. So this has period 4. So this is my answer. But I need to check the other options too. Period value. Okay, I can clearly see the cycle is this, right? And it's 2. Actually, they mentioned 2 here. Or you can see any cycle you pick, it says 2. So period is 2. I'm not looking for 2. We are looking for 4. And last option. This period goes here, here, and here. And it keep on repeating. So it's not 4 for sure. Okay, I don't know how to exactly find this, but it's not 4. It's 1 point something, right? So yes, there is one and only option, which is option B. So option B means actually this is A, this is B, Okay. Let me check. Yeah, this is C, this is D. So this is our correct answer. Okay. And moving to the last question, question number 3. Find the period of the following graph. Very simple. So I will look for maximum. Luckily, it's a easy point. So that way we can do, which is x coordinate only you should subtract 10. And here it's not -1. Every gap is 2, so it's -2. So 10 minus of -2 is 12. Okay. Other way you can look for cycle. Like I can see the cyclic pattern from, for example, here 0, then this, right? Again, this pattern, correct? So if I take a cycle, then starting of the cycle is 0, ending of the cycle is 12. Actually, it's here 12. So it's 12. You can pick a cycle and find the period, like just the length of the cycle, or you can find maximum and the difference. Correct? So that's it. And here's I have a bonus question to you. Very simple MCQ. So think well and answer this. A function has a period 10, then which of the following is true? Right? And that's it for today's video. So yeah. So keep learning and keep practicing and stay tuned with Let's Bound. Save this playlist for future reference. If you want to join student community of Let's Bound, you can scan the QR code given here. You will get newsletters and many updates, which will help you in your AP journey. Yes, that's it. Stay curious. Let's meet in next video.